Thanks, everyone. Is this working? Yeah, it's on. Okay. Well, first, thanks for coming to my presentation. I have to give a warning. This is an incredibly boring topic, which is unfortunate. You're going to be like, why are we talking about this in 2020? We're so used to it. Well, you'll get this feeling in a couple slides, so I just want to set that expectation. But I think it's useful to get some of this boring stuff done with, so in the future we can have more interesting NERVS projects, NERVS talks, and whatnot, and because people aren't focusing on trying to get the network to stay up. All right, so this is, let me just take a poll. Who knows NERVS, or who has seen NERVS or heard of it? Oh, okay, so then you don't need this orientation. Usually I have to tell people, like, this is the IoT talk in the Erlang community that's on the device, not the cloud one with millions and millions and millions of devices going to it to show all the scalability. This is us Erlang on the little device that gets put just about anywhere that you might think of. So what we want to do on this device is we want to connect these things to the network. And so at a high level, it's like, okay, I have my network settings. You can kind of see here your Wi-Fi settings. You might have a whole bunch of networks configured because your laptop or your device is connected over Ethernet, Wi-Fi, maybe a cellular modem. And then let's see, all right. Go. Okay, so then we want to somehow make that programmatic, and then that was my attempt at drawing a little robot that will make sure that wherever this device is put, it's going to pick the right thing that makes sense for the circumstance that's in. I'm going to talk a little bit more about this, but this is the problem. And it's, I guess saying it's hard is one thing, but it's time consuming for people programming this piece to make sure that it works right. And I think that the outcome has been that a lot of times that hasn't worked right. So what I'm going to do is just tell you what the conclusions are at the beginning. So those of you watching this afterwards can maybe stop at this slide if you think this is going to be boring, at least get the main takeaways. So I'm going to tell you problems, and that, believe it or not, even in 2020, there are details. There's a new network library that we have for NERVS. So those of you who have used NERVS before may have seen NERVS Network, or there have been a couple predecessors ones. Some good, some bad. VintageNet is a new one that several of us have been working with over the past year. It's been deployed a few places, and the gist of it was really to simplify some of the network configuration tasks that were really hard to do in some scenarios. And the other part was we had new requirements coming up for a lot of devices to make them multi-homed, and that whole multi-homing devices and making them be able to pick what the right thing to do is interesting. So the other thing is Extensible, because there are just a number of network protocols, devices that those of us working on the software, we just can't write everything. So then the last takeaway is if you're starting a new project, do this. The -- NERVS pack, that's will cause the new project generator to generate something that's compatible with VintageNet and pull in a lot of the dependencies that will get you off the ground quickly. If you don't put -- NERVS pack, you'll get the NERVS gadget framework, which will use the old NERVS networking. Over the course of this year, hopefully we can document, bring up all the other things in the ecosystem up to the point where that can be the default. All right, now those of you watching online can tune out if you're less interested. So the next part, I'm going to go through the whys. Why are we even doing this? So all right. Who's an embedded developer? Maybe like 20 years ago-ish. At least this is what it was for me. When I started embedded, things were really, really nice. And well, okay, it's a mixed bag. But basically, you had the device, you put all your brains in the device. Maybe you had an RTOS, maybe you didn't. Anyway, it connected to some network protocol that was very well defined and simple. It worked. You could actually reason about it. And you did all your stuff. You shipped this thing out. You didn't have to really firmware update it all that frequently because it was really kind of hard to get to in the first place. So it was so there was that problem. But the other part is that the places that I was at, we wrote pretty much every line of code on the device, and that was very comforting. It goes both ways, but at least you don't have to worry about some random third-party dependency blowing up. So then we did the IoT, and we just moved our brains to the cloud, or at least a whole bunch of them. And that's the gist. So how do we get this device talking to the cloud? And here's kind of the collateral damage slide, which the main point of this slide was that we have all these commodity networks that we now have to deal with, like you could go to something, nothing's really perfect anymore. It's just everything is flaky. It just depends on what kind of flakiness you want, either wired Ethernet, Wi-Fi, mobile. There's a laundry list of these. We just want to move the computation off our device so we can do more interesting things in the cloud and maybe make it interact with other systems that people are working with. Oh, and there's also security. I don't even know why I wrote that on there. I think that's just a tease. At some point, I'm going to have to give a nurse talk on security, or someone else will have to help, because this is another intense area that I'm totally not going to cover. But if you're interested in that, certainly hit me up afterwards. All right, so next part is where Erlang fits in. So I think everyone's kind of heard that the message for Erlang in the cloud with the IoT makes a lot of sense because of the scalability and concurrency. Erlang on the device, some people have a little hard time with, because you're like, oh, there's not too much concurrency. But let me tell you, as embedded developer, there's a lot of individual concurrency on the device with the sensors. But the real thing that I think that a lot of us are interested in this field is the reliability aspects and the ability to program at a higher layer. So we want to make this work. We have ways of making reliable pieces on the device and certainly in the cloud, but that little network at the bottom kind of it's kind of boring. You kind of think, oh, at least I always just like, oh, this has got to be a solved problem, even though you know better because you know how things work. But it's also kind of not rewarding to work on. So, but when you don't, let's see. That's kind of obvious. Things stop working. If you can't connect to the cloud and you put your brain on the cloud, then that's kind of a bummer for the device. The thing that comes up often with some of the devices going out is we're going under these very inexpensive metered networks. This has been a few companies, and devices seem to get chatty, and then of course you find out about it after the fact in your bill. So that needs to be monitored and used smartly. So the alternative, what people end up doing is they set up some system where they can work over a very inexpensive network like wired Ethernet or Wi-Fi, basically using someone else's service, and then only go to cellular as necessary. But that does take some smarts, and when you mess those things up, people get upset. Last thing that happens, one of the other things is this truck roll thing, which those of you who have embedded devices in the field, like the worst thing that you have to, one of the worst things that can come up is that someone actually has to physically drive over to wherever that device is in the hopes that you can actually drive to fix that device. It's always expensive, and anyway, people get upset with you. So I think that the bean counters will say that there's financial cost to all this, but me as a programmer here, I kind of just want these things just to work and not get anyone upset with me, and do use the tools that I have at hand to build a robust system. So this is kind of let's fix this. This is kind of me. I don't know. This has been me repetitively through my career, and I don't even know why. But it's not just me. Actually, here, maybe this could be some of you. But I cannot tell you how many people have come up to me and be like, why don't I just write the WPA supplicant in Erlang, because it would be so awesome. So maybe, but basically any network protocol, like how hard could it possibly be? So, all right, so let's just maybe, let me just beat this to death. So when I came onto Erlang, I was just like, so rolling back, I'm a C++ programmer. Erlang is awesome when it comes to these binary protocols, and it excited me so much that I was basically that guy for a while. And I think when people come into the community who have been stuck in this world of implementing these low-level network protocols or whatever, you see some of these tools and being able to operate at a high level rather than just, just for the binaries, just shifting bits back and forth and having all these little hacks together. It's so nice. Let's see. Oh yeah, that's the other thing. People are like, this WPA supplicant, like if you look at the code, and I'm being videotaped, so I don't want to rail on a piece of code I don't want to maintain right now. But it is not easy what some people have done. And the other thing is these pieces of code, some of the reasons why they're convoluted is that, number one, the protocols have evolved, but number two, it's just a complicated environment. So maybe a fresh look at these things would be useful, but that's not a small task. So yeah, how hard can it be? So, all right, so for those of you, is there anyone left in this room who wants to do this? Okay, so for the videos, about half the room raise their hands that they're still into programming everything in Erlang. Okay, so let's take an easy one. For the device, all you need to do, so when you have a device, the important thing to do first is to get an IP address for this device. Like, how do you use a LAN with an IP address? So there's a protocol called DHCP. I think many of you are very familiar with it. So let me see if I can draw this. It's all right, that took me, so this actually stressed some of my talents on this, but I had to, but at any rate, I wanted to get at the point that a lot of these protocols seemingly are well-defined. DHCP spec, it's been around. Like this spec probably talks about maybe half of it is stuff that you really don't have to do in real life. So I think it's 45 pages or so. It seems doable, right? But IPv4, right? It's 2014 or 2020. We probably should try IPv6. So what's the logical thing? DHCP6. So has anyone else gone down this path, been like, okay, IPv4, you go up to IPv6, you're like, okay, DHCP, give me an IP address. That thing's 101 pages, but it really doesn't matter because they just changed everything around. So DHCP is still relevant in IPv6, but there are other mechanisms. That's like one of the specs, but there's a whole laundry list of them. And once you start going down this route, then I guess you stop. So let me just talk about a couple of other things that come up. And really, those of you who are still left and want to implement these network protocols, I'd certainly love maybe using one of them in Nerves, or maybe a couple using Erlang implementations. It's just not a small task, and I don't want to make it out to be. And I think that so the first two are like, okay, yeah, the spec's hard to follow. The second one's, when you actually put these devices in the field, the people configure the networks in different ways, and sometimes those ways totally break the protocols. I think for Nerves, one way that hits us is for multicast DNS to discover devices. So you'd think that'd be very easy to just enable multicast DNS, and then you put all these devices out, you develop on them, and there's a whole protocol for converting names to IP addresses using that protocol, and then you find out that half the people using it are doing it on these corporate LANs that have disabled multicast, and they have no idea why none of their devices show up, and then they ask for help, and we're like, we have no clue what's going on, but this has at least come up enough that we have some guesses. This last one though, this is the one that I think really needs to be watched. It's just that people have gotten to be so insanely clever with breaking into a lot of these protocols that you have to be vigilant, or at least I think you need to allocate a decent amount of time when you release a package that implements one of these protocols to make sure that it's not doing something silly, that you're properly testing it, because it seems like it's just a matter of time before someone finds some totally, well, either convoluted or very simple way of breaking in just because you've just neglected something simple. So, no, I had a drawing, so we'll wait for that. There, that was me. Actually, that's not me. Those lessons on those slides took me embarrassingly long to learn. So, just to dig deeper into the embarrassment and hopes to save others some of the same fate that I had. So this is my history. This is my history for implementing network stacks or network configuration stacks in my embedded projects. And I'm not going to go into all these, but suffice it to say, this is not my first attempt with VintageNet. Sometimes I fear it won't be my last one, but I hope that with VintageNet, that things will be closer to something that's long-term viable in face of a lot of changing network conditions and new technologies. All right, so there. That is totally not true. So, I just want to go over the C options, right? So I'm a C programmer. I actually like a lot of C, and there are network configuration tools in C. If you've programmed an Arduino, maybe an ESP32, like some of you have done those modules. Yeah. So there's like little setup functions. They're kind of nice. You just point it at the networks. The thing is that they're very limited, and I think that this is my view of C right now, is that those libraries that are C-based really limit you to the happy path that they stick you in, and as soon as you get to something complicated, you're forced to go outside this. And this is embedded, right? So if you're working with desktop systems, this is just not even something that you would be into. The next place where I think a lot of people go, especially embedded, and I definitely am a fan of this, is Etsy network interfaces. So that file, right? You just fill it out. You have wired Ethernet. You say DHCP. It has language. There are like 1,000,000,001 examples, just to copy and paste. So, how many people read source code when it comes to how this thing runs? So this is what happened when I was reading source code. It's just like, okay. So BusyBox happens to be a very popular implementation of the tools that process this Etsy network interfaces file. And then I see this quote, and he basically, I mean, it's way too long. He went into a rant on what the problem was. It was actually quite entertaining to read the rant, so if you're interested in this, go to the BusyBox source code and check it out. So, but in its defense, I think that Etsy network interfaces is totally viable for a whole lot of situations. You just have to be aware of its shortcomings. And I think that where it hits a lot of the nerves use cases that we were seeing was just in being able to dynamically change things, and also in kind of I think this last one it felt unsatisfying. I think people using this interface end up doing a lot of shell scripting, and when you're programming in Erlang to drop down the shell scripting is sad. And and then the other thing, the unsupervised daemon. So you start all these C processes to run the network, like the WPA supplicant being one. What happens when it crashes? Well, it goes away. Luckily, it didn't crash too much, so everything was okay, but I don't know. With this community, that probably doesn't give most of you a warm fuzzy, because we do have tools to do better. All right. Then the final two that are kind of popular, and I lumped them together even though they're completely different. So there's connman, systemd. I bet a lot of people know systemd, but connman's very popular on the embedded side. It's say if you're doing a traditional C-based, C++ based embedded project, this is probably the easiest way to go to deal with like multi-home networks, to switch between wired, wireless, to have some sort of dynamic capability of having your program interact with these networks and switch as necessary. Then let's see, I just want to mention systemd. There are a decent amount of embedded projects that pull in systemd, and I guess depending on who I talk to, systemd is either very good or very bad, but it is an option for a lot of people embedded and does simplify some use cases majorly with some costs, but it can handle networking. And I think that if you subscribe to the systemd worldview, that using it to do a little bit networking too kind of feels okay. So now the question is why aren't we using those two in nerves? Why do we have to invent our own thing? And the answer was we could use it, right? So nerves, those of you who've used nerves, you can pull in traditional embedded Linux tools to manage things, and people do that frequently, and they pull in systemd, and they pull in connman. But what happens with their programs, so both system and connman like to use dbus, and then you start getting to the situation where I'm in Erlang, sending messages back and forth, but now I need to interact with these tools. And so you start ending up going through dbus, and then someone else on the team was just like, okay, well, I'm working through this, so maybe I should just code this up in C. And then they start switching to C for something that you would have normally written in Elixir and Erlang, and your project starts switching back and forth between who's working on the project, because the C stuff is very viable with lots of examples. The Erlang stuff is too, and there's kind of this impedance mismatch, and there's confusion. So works, but it's, I think documentation-wise for us as a community, it was not something that it's not a path we wanted to go down due to this additional complexity and overlap. All right, so then I got to the Elixir. I'm going to be very quick on this, but there are a couple things that I have learned on Elixir. So I would like to say that I know I've been around for a while, but sometimes I feel like very much of a novice in Erlang and Elixir. And some of this, my Elixir and Erlang, I view as very simple sometimes, and I like that. But I'm also very much learning and trying to improve things. So for those of you who are perhaps in my situation as well, let me just tell you what happened, some mistakes I made. So Nerves network, this is the current Nerves networking stack. And back when I wrote it, I got really excited because I could express state machines very nicely in code. And a lot of the ways network works, like your Ethernet interface comes up, that triggers an event that goes to the state machine to go back to to start kicking off a DHCP request. There's a lot of state interactions and a lot of air conditions in that state machine. And it's not many states. I don't want to make this out to be like a really big and hairy state machine. I think it ends up being like a hint, 3 or 4 states, just with a lot of events going back and forth. But when I wrote that up, a lot of the logic was in gen servers, and it was incredibly difficult to test this code. And when I did that, so what we do is everyone who'd work with Nerves Network would know that before you ship a new release, you check, does it connect up to my home LAN, right? Or to this router, the Wi-Fi. And basic checks could exercise a decent amount of those state machines, and people were generally afraid of modifying them anyway. But then we got to the point when once we got enough features in, then it was like totally impossible. And no one on the Nerves core team wanted to have anything to do with this thing. So I think Connor Rigby and I would draw straws, and we knew that a few fixes need to get in, and it's just a matter of which one of us would actually test it. So I wanted to point this out. This book has actually been incredibly influential to me, and the whole, and I think when I say this out loud, I almost have thinking that this is like just something that everyone just knows in this community, but it was like, this was amazingly hard for me to internalize, and I still reflect on how this could have been so hard for me to internalize, to pull out so much of my logic to try to make functional, pure functional modules and do all my testing in that, and then have the bare minimum in my processes, my gen servers, that calls out so that I could have some very easy to test code, the functional core. That book put words to it for me.
I love you, man.
Oh, hey, Bruce, I love you too. So, anyway, it helps me. I really think that some of these concepts, I'm not even sure they've been around, but somehow putting the words to it made it that much, made it help me. So anyway, that's my spiel on that. So, all right, let's switch over to the main topic, which is what I wanted to tell all of you about, which is this new network stack called VintageNet. And when we started this, we wanted to do some things different from nerve networking. And the main idea is we're going to take some user-friendly configurations in maps. You know, it's kind of like that Mac setup menu, except imagine that as kind of a nice map data structure that you can kind of read and kind of get a feel for what the configuration is going to be like, and then translate that into the low-level configurations for whatever Linux tools or other tools would be processing those. So what we do is we test that translation layer. So if you could imagine, if you've used like WPA supplicant, right? This is something to manage wireless. There's a config file. It actually is there are a lot of options into it. But when you configure a network, that's just one of the many components. So the idea was we take something that humans and maybe machines can deal with, translate those to configurations for tools that are independently tested. And I'll get back to that. So the other thing is we weren't going to try to tackle this. How do you change, if you're going to change the configuration of a network, how do you do a partial change? The state machines were really nice in that you could do partial changes of networks. And the nice thing with partial changes is that if you're doing something that shouldn't drop connections, like say you have a connection to a server and that TCP connection's there, and you're modifying, I don't know, some like interface priority or something like that, we're going to modify that in place, and it won't change the IP address. Your connection won't be dropped. It won't have to be reestablished. And if you're a C++ programmer, or even if you just like the purity of all these things, it's really nice when connections don't get dropped, but that comes with a cost. And going in constraint was we weren't going to deal with that. Any change, shut down the network, bring it up. Doing anything better was an optimization. That saves an unbelievable number of edge cases. All right, so and then last one was we can use Linux for everything, right? So if you have some new network technology, right, you're not going to have to rewrite. You're not going to have to do a lot of coding in Erlang. Just call the Linux command that runs it, right? That's a good starting point. And that's how we started implementing this. So the first versions of VintageNet would just call IF up and IF down and create like Etsy network interfaces. And I'd hang my head in shame, but not really, because it worked and it got us started and it was quick. So, all right, simple, reliable, testable, extensible. So let's go through these one by one. There's a small API. VintageNet, these are almost obvious. Configure, if you want to configure something. Info is kind of our debug method. So if you are having trouble, call vintagenet.info. It'll go through, tell you, if you have wired Ethernet, you are connected to the LAN, or maybe you're connected to the internet. Here are settings on it. Same with Wi-Fi, mobile, same thing. That's first level diagnostic information. Then these last two, get and subscribe. These let you introspect on various aspects of the network. So you could be an IP address, or like if you have a wireless LAN, say you have the wireless card scanning for our access points, you could subscribe to property on there that says what the current access points are in range, so that you could link that to some sort of user interface that updates in real time for someone to see. All right, this built-in persistence. So the expectation that pretty much everyone had going in with Nerve's network was that if you set the network settings to like connect to this Wi-Fi thing dynamic at runtime, and then reboot it, that it would somehow connect afterwards. And right, why would that be the domain of Nerve's network? That's on you to save and load the settings, right? That's what I thought. But after everyone did that and asked why their settings were getting lost, it seemed like we should build that in. So it's built into VintageNet. You can, of course, turn it off because maybe some people don't want to have it saved to the location. So then the last thing, okay, then there's a cookbook. So if you go to the website, you can see there's a cookbook that you can copy paste from. All right, reliable. We supervise everything. This is like table stakes for our community. The interesting part about this is that while we supervise our seed daemons, so if they crash, they'll be restarted. The system will restart, will clean up and restart in a sane way. It also works the other way. So that's kind of the one things with supervision, that the Elixir site could crash, that supervision tree could come down, and it needs to take out the C daemons from running too. And I think that almost happens more often with a lot of the code development that we do. And that's a feature, because if one of those C daemons stays up and the supervision tree comes down, comes up, and it tries to get started again, it's not in a good state and it would fail. So anyway, it's both ways. And then clean configuration changes. So I think I talked about this a little bit, functional core. Already talked about the configurations, more like a configuration, high-level configurations to low-level configurations. There's also a lot of route calculations, and these aren't like physics calculations. It's just which Ethernet or Wi-Fi, which interface are you going to use? How do I configure the Linux system routing tables properly? And that all can be done in a pure functional way. All right, and then the extensible part. So VintageNet by itself doesn't know how to do any networking. There are other projects, and you can kind of get a feel for them there. So the current ones on the website are the Ethernet Wi-Fi, which I think are self-explanatory. Mobile is for that one's under development. If you have it supports a couple LTE modems, and if you happen to have those two, it'll probably work out of the box. If you don't, it's probably a little change to add yours for the tweaks that are needed. That last one, VintageNet Direct, this is for if you have your device. This is more of a development setup where you have your device over a USB cable plugged into your computer. It has a virtual Ethernet cable that goes in there, so you can you can communicate with your device over that one USB cable. So it's like the peer-to-peer setup. All right, so let's see this in action. So first off, interface naming. Those of you familiar with Linux, kind of familiar with these, it reflects whatever Linux shows them up. So you can do the predictable network thing if you're on a system that's important. So predictable network is the network name has the path in it, so that you know exactly which interface it is. It's not set up to maybe happen that randomly your second Ethernet interface comes up before your first one and get the numbering out of order. All right, so IP addresses, you can see this. You can either use strings or tuples. Internally, VintageNet converts everything to tuples. I think the learning that has occurred here is that no matter how many times people see tuples in Erlang, someone always passes in strings, so we might as well accept them and convert them to the right thing. But for all those you listening, these are the functions. So the Elixir people out here, there are a couple functions that make your life much easier when you need to convert between the two. All right. Here's a slide that shows kind of the code for what you need to set it up. The two options here, right? You can hard code it in your application config. So VintageNet, you basically list out your interfaces and the configuration. So where I have ... that would be the configuration data for that interface. Or you can call things at runtime. And of course, if you call it at runtime, that's persistent by default, which would override any hard-coded settings. So the general strategy here is set up something that might work out of the box on a clean build for your device, but then your application is probably going to be calling these. All right, so got the Ethernet one. And let me just show you. I think that Ethernet is probably well understood here. DHCP, so you basically have dynamic or static IP address. This is the dynamic way for IPv4. So you put the type, you point it to a module that implements the Ethernet behavior, and you tell it for IPv4 DHCP, and that will get you an IP address. This works for, I don't know, most networks out there. If you look at I'm not showing it here, but if you want to statically say what the IP address was and all that stuff, you would list it in using words that probably would ring a bell if you've ever done this in one of your system dialogues. All right, so let's get to the more interesting setups. So this is the Wi-Fi 1 device going to an access point to a router. So what does that look like? This is the pre-shared key setup. So most home networks, you can list out multiple networks, so things are stored in a map, and you say what the key management is and the SSID and the key. So there's actually subtlety. The actual key that's used on the wire is computed. So you put in whatever word you want, and there's a whole algorithm for generating the thing that's technically called the PSK. So VintageNet will do that for you behind the scenes. So let's see. All right, this was one of the things that people really wanted to do with Nerves, and took a lot of work with Nerves Network, which is having a captive portal. So this is the idea: is you have your device set up, and it's an access point. So someone else can take their laptop or phone, connect to you, go to a web server on there, and do configuration-like things. So how do you set that up, or what kind of things are involved? So there are Wi-Fi things. So that's this left part. So you can kind of see this, the magic line, the mode, AP versus infrastructure. The right side, so we have a static IP address, right? So because this is now the router, but the interesting part is you can set up a DHCP server. This will be a Linux-based DHCP server that allocates IP addresses to devices connecting to it. And then the captive portal piece, the DNS. So there's actually a little bit more to this, but for simplicity, I just showed the DNS server is just going to redirect star to us. So kind of makes sense? Yeah, so this just saved like, I don't know, 1 million lines of code that in the previous generations. All right, so when you're interested in this kind of setup, so when we built this, and then some people said, well, I'll make the web server for you. So we're like, great, help us build the web server that people use to configure that. So this diagram is showing this setup. So the web server is called the VintageNet Wizard now. The web server gets enabled. So the way this works is the library connects up to a button, right, on the box, or it could be instigated by anything. You have to wire that piece up, but the idea is you press the button, it starts up the web server and turns the device into AP mode, and then you can connect to it. So here's, let's see if I can, here's a little bit about what that looks like. So anyway, this was a whole lot of work done, a lot by John Karstens and Matt Ludwig's, and I think it's really going to help people deliver simple Nerves devices into the field. All right. So, all right. So the last thing, the last thing that I wanted to talk about or just share with you is the routing, because at the beginning I talked about this whole multi-homed routing. How do you switch interfaces? And it's kind of interesting to one respect. So I just wanted to give like a little taste. So imagine this picture. So the device, I have it doing Wi-Fi right here in the drawing, but you could also imagine this be a mobile and wired Ethernet one setup where the device just wants to connect to the cloud, and it's going to switch to the cheapest interface. So the cheapest interface would be Ethernet in this case, or and then the Wi-Fi would be considered more expensive because it's either flakier, or if it were mobile, it would actually be more expensive. So if we look at the info, here are things that are monitored. So you can see the connection level, or the connection is, each connection is monitored with VintageNet, right? Is it on the LAN, or is the internet accessible? That's just by querying a website, or if the technology has some way of getting at it, it could go through that. So this is the guts. So again, I'm going to be brief on this because Linux networking is like a deep subject, but at the end of the day, what Linux does is it looks at things on the right side. It has these tables, these routing tables. The routing tables say, I have this destination address, where do I go? So that's kind of, so what I've shown in those boxes is the default. So I have, if we just look at routing table 100, that says, I want to go to the internet, and somewhere on the internet, I'm going to go via that IP address. That'd be my default gateway, or that would be my gateway, and it's off of Ethernet 0. If I were going to the LAN, there's actually another rule that I didn't show, which says if I'm going to this subnet, it's on the LAN, I can just go direct to it. So you end up having a bunch of tables. And then stepping back to the left, there are rules. Rules say which routing table do I need to use. And so this would be, if you're communicating with someone over Wi-Fi, you want to keep on communicating to them over Wi-Fi. Right, so that's the rules. Inspect the source IP address, among other things, to work with the tables which inspect where you want to go. So you can introspect all this stuff with VintageNet and with the Linux command line utilities. But VintageNet sets this stuff up so you can kind of see that. Let's see, the thing that I want you to see, that these tables are visible here. If I go back, this maps to rules and routes with the tools. So if you ever want to see this stuff, you can do that on Nerves. But you can do that on any system that has these tools, the IP tool. So let me get the label here. Oops, didn't have the label. All right, so this is the key one. VintageNet will set it up so that the default route, like if you're just making a connection up, which do you pick? The wired Ethernet or Wi-Fi? The ETH0, the wired one, comes up first. So if there's Linux gives you a way of prioritizing them. VintageNet will reflect that prioritization in there. So this would be Wi-Fi and Ethernet both working. Let's kill it. Let's kill the wired. And then if you were to re-show it again, the priority for using the wired Ethernet would drop down. It wouldn't be used at all unless you were actually going to something on the LAN with that kind of setting. All right, so just finishing up. If you want to use this today, you can. It's out there. It's just non-default setup for Nerves at the moment. This is basically where we're at. I guess an asterisk on enterprise Wi-Fi. Those of you doing enterprise Wi-Fi, we tend to support like only a couple of the protocol profiles for enterprise Wi-Fi, and that's merely because that's what we have to test. The suspicion is that the other ones work, but this is a pretty complicated piece to set up for some corporations. All right, the progress part. I think talked about the cellular modems and the official stuff. This Wi-Fi wizard that I showed you, that one's getting a lot of interest. So there are people looking to improve that. So hopefully that will get out there soon. And that's kind of exciting to see people build upon that piece. All right, so here's the takeaway. Mixnerves.new if you want to use it. And then do this stuff before you file issues. Actually, if you're going to file issues, all your problems are really hard. So I'd appreciate a Wireshark dump, and then I'll help you, and then it'll be easier for me to help you. It seems like this community doesn't give me any easy problems anymore, so which is good and bad. But network doesn't work is pain. All right, so anyway, thanks. I mentioned a few of these names before. So SmartRent funded a lot of my time on it. FarmBot, any FarmBot users, thank you very much. All this code was deployed to you like way early on. And then John for NursePack. So that's it. So thanks, everyone.
We are almost in the time, but I think that we can have, there is one question, someone?
I'll take questions after. Wait. Sure. I can repeat it.
Quick.
So how much were you able just to delegate back down to Linux? Like how much of this did you have to code yourself versus using the tools? You mentioned some of it.
Yeah. So the first round of this, everything was delegated. It was very simple. The configurations would go down to IF up down scripts, and I think as we've progressed, we've taken some functionality out because there's some things that are kind of easy to do, and it just was way easier to implement that in Elixir. But that's like really small pieces. I think I'd say that VintageNet right now is predominantly using the building block Linux tools. So thanks.
Thanks, Frank. Please.